All right, 26. I'm actually going to forego 26, so I'm going to give you that one. Okay? So you don't have to worry about that. Asymptotes remain in range. That's probably something I shouldn't have had on there. So 26, make yourself a little note on your note card, 26. And remind me so I give everybody the answer for it. Does that sound good?
Yep.
So, I remember, I'll write that up here so I remember. Twenty-seven. 27, as we get down there, what's good about 27? Has the same denominator, okay? So it is a nice, simple problem. We can say 7x equals 5x plus 10. We'll subtract 5x. We're gonna get 2x equals 10. Solving there, we'll get x equals 5. Now, when we take that and plug it back in, what happens to our denominator? It becomes undefined, so there's no solution here.
We're playing Hudson G, Joe Marshall, at Chandler at 5:30.
Okay.
If you're interested.
Yeah, thank you, that's
Pass it
right.
on that. There.
28. We need sets of 5. Okay? So 243 is a perfect 3 to the 5th. So that 3 is coming out. We have z to the 10th. We need sets of 5. So it's going to be z to the 2nd. So 243 is 5 3s, if that makes sense to you. I hope it does. Because this is the 5th right here. We need sets of 5. There's nothing left over. And that's it for that guy. $29, is that where I'm at? Write the expression by using a rational exponent. So this would be 5 to the 7/9. That's a pretty easy one, isn't it? Some of these are easier than others. Solve the equation for number 30. You gotta isolate the radicals, so to start with, I'm going to say plus 4 on both sides. Then I will be left with the square root of x plus 5 equaling 1. So we get it isolated. Now we'll take and square both sides. Squaring something squared becomes that. That, my friends, is just 1. Now we'll solve by subtracting 5. So I end up with x equaling -4. You do want to check that and make sure it doesn't make my radical go to the negative number, which it doesn't. -4 in there would give me 1. Square root of 1 is 1, and -4 minus 1 would be -3, and -3 is equal to -3, so it is a good solution. It does work. Sometimes when we square both sides, we can get extraneous solutions. This part should be a lot more familiar with us. Why? We just finished it, didn't we? Okay? So these last 10 questions should be ones that you can make some hay on. And not have that much trouble. Here's our theta. So this would be the opposite, this would be the adjacent, and this would be our hypotenuse. Of course, the sine is your opposite, which is 32 over your hypotenuse. Now, I'm not sure if my answer, it's a multiple choice, if they're going to be, reducing the fraction or not. Sine, cosine then, going to be your adjacent, which would be 24 over the hypotenuse. And your tangent would be opposite over adjacent. (32). The ratios are x and x square roots of 2. So we're going to take x square roots of 2 and set it equal to 20, because that's what that side is equal to. Now we need to solve for x, so I'm going to divide by square root of 2. We will continue by rationalizing that. So we're at 20 square roots of 2 over 2 now. And of course that 20 and 2 reduced to 10 square roots of 2, which would be both sides of this 45. Are we okay there? Drawing an angle in standard position. Of course, we'll draw a, ooh, there we go, we'll draw a having fun now. Come on now. Swap for a little bit. Okay, so we'll put a circle around it if you want, but I'm going to start on the initial. That'd be 360. That'd be 720. So just a little bit up in there. And that would be it. Your reference angle would be 8 degrees there if you were thinking about referencing. Number 34, shame on you if you miss it. You should write on your note card, number 34. Plus and minus what? 360. Just simple code, terminal angles. Plus or minus 360. We're on 35, is that right? Again, these should be feeling pretty good because we just finished these up. So we have 114, initial side, 114 will put us up in here somewhere. And we're going to get back to the x-axis as quick as we can, which would be coming this way. So that reference angle would be the difference between 180 and 114, which would be 66. Pi over 10 from radians to degrees. So we have pi over 10. We're going to multiply by 180 over pi. Those pi's cancel. So you end up with 180 over 10. Which simplifies to 18 degrees. You okay? I'm not going too fast, am I? Again, this should be pretty familiar. We just finished this up. Now, some students draw the whole unit circle out on their card, but I know if you've studied it a little bit, you really don't need to do that. Exact trig value function of cosine of 30. So cos of 30 is my x value. So we've done a bunch of these. 30 degrees would be right here. There's your right. You're looking for the x distance, which is right here. Across from the 30 is 1/2. Across from the 60, square root of 3 over 2. So my x there is positive square root of 3 over 2. Gonna do the same thing, reference angle, we got another cos of 150. Now this one's obviously in a different spot, but it is the same family. So 150, we're still looking for the x value. And over here though, it's negative square root, because there's my x value. So the cos of 150 is gonna be negative square root of 3 over 2. All right, you're gonna have to solve for the other sides of this triangle, so this will be the law of sines. You might want to have that in your notes if you need it. There will be no formulas anywhere from me, so angle N is 119, angle P is 34, and side M is 11. So it is an angle side, which makes it very nice for us. We can find that other angle by the sum of the interior. Let's see, 119 and 34 would give me 153. Is that right? 153. 153, and so the other angle would be 27? 27. Did that in my head. So there you get your angle M. Now we'll be ready to use the law of sine. So the sine of 27 over 11 is equal to, doesn't matter, sine of 34 over P, and it's also equal to the sine of 119 over N. So you're going to be solving for angle M there, and inside P and side N. We've done a bunch of those. You should be all right there, correct? What do we always want to check then? To make sure the longest side has the longest angle and the shortest side has the shortest angle. So we're at the one that we've been looking for all year long. You know what this problem is? The last one. The news is I will be giving you no more problems, no more new problems. Yay. Not to get sentimental, but they were already back there saying, this could be the last class we ever have together. All right, this one takes a little thinking. 2 airplanes leave an airport at the same time. One flies east, 300 miles an hour. The other flies at 350. The angle between the two directions is 22. Okay. So they're kind of like, here's the airport. One's taking off this way. One's taking off this way. This is 22.5 degrees. Make sense, my friends? Now, there's a little trick in there. One's going 300 miles an hour, the other one's going 350, but they do it for how many hours? 2 hours, okay? So that's the trick. You gotta be careful there. So one of them's gonna be 600 miles, and the other is gonna be what? equals 700 miles. And you, my friends, need to find this distance right here. So we can just call that A. So remember, we're looking for side A, so side A squared is equal to B squared plus C squared minus 2 times B times C times the cos of 22.5. Remember, definitely use brackets there. Not sure what it is. Katie, you all right? Oh, I was just slumped over looking at your, looking at, oh yeah, you're looking at your phone. How we doing, ready? Just like usual, 40 questions, are just like 40 questions on the practice. Multiple choice. Students say, how many points is it worth? And it's worth 40 points. Doesn't matter. It's the exam that's totally separate from anything else, so. If I made each one 5, that would be worth 200 points. I'm just taking 5 off for each one. It doesn't matter if I make it 40 points, take 1 off for each other. It's all mathematically the same. Do you understand that? All righty. Thank you very much.